Today we're going to talk about how to find the discriminant. Okay, and the discriminant is the new term, but it's actually something that you already know. The discriminant refers to the part of the quadratic formula that is underneath the square root. So it's going to be b squared minus 4ac. Okay, now we don't actually take the square root as part of the discriminant. It's just the b squared minus 4ac. So part under the square root. So we're only referring to b squared minus 4ac. And so the discriminant will tell you a few things about the types of zeros that you have. Remember last week we talked about how to find the zeros. So we can have positive zeros, we can have no zeros, and we can have negative zeros. Alright? So if the discriminant, b squared minus 4ac, is positive, then you will have two real zeros. Zeros. If the discriminant equals 0, then what's going to happen is you will have one real zero. We also call those solutions, remember? And we call them roots. Those are all the same term, so don't forget that they can be solutions, zeros, or roots. And then the final option is that this number underneath the square root can be a negative number. And if that number is negative, then we have no real solutions. That would mean that the graph of the quadratic function never touches or crosses the x-axis, because that's where our zeros are. So let's see what this looks like in the problem. So they give you an example, and they ask you to find the discriminant. So what you do is you take a, b, and c, and you just plug them into this part of the formula. So we're going to do b squared minus 4 times a times c. So we're going to do 4 squared minus 4 times 2 times 1. Just the part that's underneath the square root. When we do that, we get 8. So since this answer is positive, that means we're going to have two real solutions to our answer. So if you were to graph this on the calculator and find out where it crosses the x-axis, it would cross twice. It doesn't tell you where it crosses, it just tells you the discriminant. It just tells you that it crosses 2 times, 1 time, or 0 times. Same thing here with this example, 2x squared plus 4x plus 2. If we plug it into the b squared minus 4ac, which is the discriminant, we're going to get 4 squared minus 4 times 2 times 2, and that's going to equal 0. Because it equals 0, that means there is one real solution. So if I were to graph this equation, that means it would cross the x-axis or touch the x-axis one time. And then the final option is that the answer is negative. So if we plug this into the formula, 4 squared minus 4 times 2 times 3, when we type that into my calculator, you get negative 8. Okay, so because it was negative, that means there are no real solutions. So what that means is that if I were to graph this equation right here into the calculator, I would have nowhere on the graph where my graph touches the x-axis. No real solutions. Alright? Now, there are things called imaginary solutions, and that's what we're going to talk about here in just a second. But before we move on, just remember that the discriminant is only the part underneath the square root, b squared minus 4ac, and that you have three options. 2 real zeros because it's positive, 1 real zero because it's 0, or no real zeros or solutions because the answer is negative. Now, what happens if you have no real solutions? What does imaginary solutions look like? What does that mean? Well, if you move down here to the bottom of the notes, you'll see something that we haven't seen before. We've got this letter I. Alright? We've got the letter I. Imaginary numbers are represented with the letter I. That's what we use to represent imaginary numbers, this letter I. Okay, and this is supposed to be a square root right here, but the computer did draw it, so go ahead and extend your square root there. So, what the letter I represents is an imaginary number. An imaginary number is a number that doesn't exist. Obviously, that's why it's called imaginary. But the definition of an imaginary number is remember that we cannot take the square root of negative numbers. We've talked about that. It has to be a positive number in order to take the square root. Well, sometimes we get negative numbers inside a square root and we want to be able to simplify it as much as possible. So what we do is we take I, okay, and what I equals is I equals the square root of negative 1. So what I do here essentially is I've got the square root of negative r. And so based on that right there, I can break this up into the square root of negative 1 times the square root of r. That way the r is separated from the negative sign. And then what we do is we use I to represent the square root of negative 1. So instead of writing the square root of negative 1, we write I times the square root of r. And then we can break down r and keep going along with our problems if we need to. So what I does is it allows us to take out the square root of negative 1 and then continue simplifying the problem. Tomorrow we're going to work with I a little bit more. So one thing you need to know for tomorrow is that if you have I squared, that's going to be, remember, the square root of negative 1 times the square root of negative 1. And then the square root of negative 1 times the square root of negative 1 is going to equal negative 1. So I squared equals negative 1. You won't actually use that information today, but you need to know that for tomorrow. So today what's going to happen, and when you see these imaginary numbers pop up the most, is when you're trying to use the quadratic formula. And when we use the quadratic formula, sometimes the numbers we get inside the square root are negative, as we just talked about up here at the top of the notes. And so when that happens, we have to be able to use I to simplify our problem. So let's look at our first example here. 3x squared minus 7x plus 5. We're going to use the quadratic formula. Remember, negative b plus or minus the square root of b squared minus 4ac all over 2a is my quadratic formula. So the first thing I want to do is I want to identify what a, b, and c equal. So in my first example here, a is 3, b is negative 7, and c is 5. So I take a, b, and c, plug them in the quadratic formula. Remember, we've already done this. So 7 plus or minus the square root of negative 7 squared minus 4 times 3 times 5. All over 2 times 5. So, plug the numbers into the quadratic formula. Then remember, once you do that, you want to take what's inside the square root, which is called the discriminant. We learned that just today. Take the discriminant and type it into your calculator to simplify. When you do that, you're going to get 7 plus or minus the square root of negative 11 over 10. So when I type this into the calculator, I get negative 11. Oops! I can't have a negative number inside the square root, so I have to simplify. So what we do is we use this information we learned here about I representing the square root of negative 1. And so what you're going to do, since you have a negative number inside the square root, you're going to take an I outside. And when you take I outside, you see the r turns to positive. So the number inside turns to positive when we remove I. So this is going to equal 7 plus or minus I square root of 11. So 11 stays positive now, and then this negative 1 we move outside and turn it into I, all over 10. I can't do any simplifying here, so then this right here becomes my final answer. This is the same process that we used when we did the quadratic formula the first time. The only thing that is different is that now we have a negative number. And so what we do to get rid of this negative sign is, in front of the square root, we put an I, which stands for the square root of negative 1. Alright, let's try this second example here. Let's see what we get with this second example. We've got negative 4x squared plus 5x minus 3. So a is going to be negative 4, b is going to be 5, and c is going to be negative 3. So we plug this into the quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. So negative b is going to be negative 5 plus or minus the square root of 5 squared minus 4 times negative 4 times negative 3. And all of this is over 2 times negative 4. So again, we take the discriminant That's the part underneath the square root. Type it into the calculator. When you do that, you're going to get negative 23. So we have negative 5 plus or minus the square root of negative 23, all divided by negative 8. So again, I realize I have a negative number inside the square root. So what do? We take I and we take it out. So that becomes negative 5 plus or minus I square root of 23. 23 becomes positive when we take I out, all over negative 8. And then the last thing you want to do here is you look, I've got a negative number divided by a negative number. Remember, a negative divided by a negative is always positive, so we want to simplify this and make it 5 plus or minus I square root of 23 over positive 8. This is 23 right here. Negative divided by negative is positive, so we simplify that to make it a positive. Okay? Last example we're going to do here, 6x squared minus 3x plus 1. So the first thing we need to do is identify A, B, and C. So it looks like A is going to be 6, B is going to be negative 3, and C is going to be 1. So we got 6, negative 3, and 1. Quadratic formula. Plug it in. Negative 3 makes positive 3 plus or minus the square root of negative 3 squared, remember your parentheses, minus 4 times 6 times 1, all divided by 2 times 6. So again, we plug this into the quadratic formula. We take our discriminant, which is the part underneath the square root, type it into my calculator, and that's going to give me 3 plus or minus the square root of negative 15 over 12. Got a negative number inside the square root. So we take out I. 3 plus or minus I square root of 15 over 12. Took out I, made it positive. Now, 3 and 12 can simplify, but there's no number here that simplifies with 12. So there's two things you can do. You can leave it like this, but most likely what they're going to want you to do is simplify 3 and 12. So 3 divided by 12 is 1 over 4, plus or minus. So I did 3 divided by 12, got 1 over 4. Now I have I times the square root of 15 divided by 12. So that stays I square root of 15 divided by 12. And this here would be my final answer. So what I did essentially was I used the plus and minus sign here to make two separate fractions. One was 3 over 12, and the other one was I square root of 15 over 12. I was able to reduce 3 over 12 into 1 over 4. I could not reduce I square root of 15 over 12, so it had to stay like that. Alright, so let's turn your notes over to the back and let's do an example of a problem where you have a negative number inside the discriminant, but you also have to simplify the radical before you can solve the problem. So we've got 5x squared minus 2x plus 3. So we're going to plug this into the quadratic formula and try to find the roots. This actually should equal 0 so that we can plug it in the quadratic formula. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, the first thing you want to do is find a, b, and c. A is 5, b negative 2, c 3. You plug the numbers into the formula, we're going to have 2 plus or minus the square root of negative 2 squared minus 4 times 5 times 3 all over 2 times 5. Then what we're going to do is take what's inside the square root, type it into our calculators. When we do that, we get 2 plus or minus the square root of negative 56 over 10. So we notice that we have a negative sign, so that means that we have to take out I. So the first thing we want to do is take I out. 2 plus or minus I square root of 56 over 10. Now that we've taken I out, we see we have the square root of 56. So what you want to do is you want to take the square root of 56 and you want to break it down like we've done before. 8 times 7, 4 times 2, 2 times 2. So I have a pair of 2's. Remember, when you make a pair of a number, it goes outside. there's an I outside of my square root. So I take this 2 and I put it with the I, and it becomes 2I. So I'm going to have 2 plus or minus 2I square root of 7 times 2 is 14 now on the inside, all over 10. So I've broken down 56 now into 2I square root of 14. Then I look and see if I can simplify. Yes, I've got a 2, and a 10. And since I can simplify all those numbers, I go ahead and do that. That's going to give me 1 plus or minus I square root of 14 all over 5. Divide everything by 2 because that's the number I can take out. And that leaves me with 1 plus or minus I square root of 14 over 5. So if you have a number inside the square root after you take out I that can be broken down, you need to go ahead and do that and then see if you can simplify before you come up with your final answer.